Welcome, good morning. This is my first in a series of videos on our Term 1 Pure Maths 3 exam, and I'm going to start in this video with questions 1 and 2. Question 1 is on your use of logarithms to solve equations, and question 2 is using what you've learned about trigonometry. Okay. So let's have a look at question 1 now. We have this question here. We've got 5 to the power of 3 minus 2x is equal to 4 times 7 to the power of x. The first thing we're going to do is take a logarithm of both sides, and I'm just going to do log base 10 of each. Like this. How have I got this little bit here? Well, I'm using my laws of logarithms here. If I'm taking a law of this multiplied by this, well, we can say that that's log base 10 of that plus log base 10 of that. So a log base 10 of all of that is equal to this using our logarithm laws from chapter 2, I think. Okay. Now also another logarithm law is that we can use this here to go 3 minus 2x bracket log base 10 of 5, and we can do leave this as is for now. Well, actually, sorry, at this point we'll pop this x over here plus x log 10 base 10 of 7. So using one of our other logarithm laws in both of those cases to bring this power in front of the log. Hope you remember that from chapter 2. Alright, now I'm going to expand this out. So I'm going to have 3 log base 10 of 5 and minus 2x log 10 of 5 equals log 10 base 10 x log base 10 7. Now I'm going to gather my like terms, so I want to get my x's over to one side and then my non-x's over to this side. So I'm going to have 3 log 10 5 minus log base 10 4 is equal to x log base 10 7 plus 2x log base 10 5. At this point we're just about there. We're going to factorise this side. So this side remains the same. So I'll have x into log base 10 7 plus 2 log base 10 5. Okay? And then to get x by itself, I'm going to take this whole side and divide it by this, and that will give me x. Now if you do that, you should get, and this is what I've got, 0.666. Okay, so that's the answer to the first one. Alright, so now let's move on to question 2, and the question we have here is, what is the question that we have here? Okay, we've got f of theta is equal to this, and we've got to show that this equals tan theta. So I hope you can see the big clue in this question. It's a big clue because we've learnt about this, haven't we? We've got sine 2 thetas and cosine 2 thetas. So we're using the double angle rule. Okay, so my first step would be, I'm going to say that it is equal to 1. Now if I'm trying to get tan theta on the top, tan theta, I need a sine theta on the top and a cosine theta on the bottom. That's what I need. So I've got to think about that. Well, my cosine theta, I'm going to turn it into, what's my rule here? I'm going to have a look at my double angle rule. It's 2 sine squared theta. No, 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. That's nice. Okay, and I know that the sine 2 theta is equal to, I think it's 2 sine theta cosine theta. Just check my rule for that one. Yes, that's correct. And then on the bottom, I'm going to have 1 plus, and I'm going to change maybe this one, I think, to a cosine theta. So this will be 2 cosine squared theta minus 1. And then, so this one, I've changed into this, because remember I'm trying to have sine theta over cosine theta. Okay, and then this one, again, this 2 sine theta on the bottom is simply that. And at this stage you might be thinking, oh, this is looking pretty hairy, I'm not sure if this is going to work out. Well, we'll just stay the course and see what happens. Okay, 1 minus 1 is 0. Minus 2 sine squared theta is 2 sine squared theta. Plus 2 sine theta cosine theta. That's our top. Now let's look at our bottom. 1 plus minus 1, that gets rid of that. And then we're left with 2 cosine squared theta minus, oh, that's gone, that minus 1, sorry. Yep, got rid of that. Plus 2 sine theta cosine theta. Alright, what can we do at this point? Well, we probably want to see if we can factorize. So out of the top, I'm going to take 2 sine theta. And then that means that the first term is sine theta, because 2 sine theta times sine theta is, of course, 2 sine squared theta. And then this one is just going to be simply cosine theta. 2 sine theta times cosine theta is 2 sine theta cosine theta. Now out of the bottom, I'm going to take 2 cosine theta. And then I'm going to have cosine theta for the first term plus sine theta here. Now I hope you can see at this point we've actually solved the problem. We've proved what we needed to prove, because this can simply be rearranged to sine theta plus cosine theta, and that cancels out that, and that cancels out that, which leaves us with tan theta, which is what we needed to prove. I hope that makes sense.